Okay, so today we're going to discuss something somewhat exciting. We're going to discuss the culmination of what seems to be the most successful citizen science project ever. The final analysis and final interpretation of data from the project that quite a few of us have participated in back in the days, the super famous SETI at Home. The project that I was also running on my computer for several years, back when I was in college, and the project that over the years collected approximately 12 billion individual signals. But now, after several decades, we have our final release and the final analysis discussing exactly what scientists have discovered so far, and of course discussing the next steps. And so essentially after approximately 26 years, and after the participation of over 2 million volunteers, including yours truly, SETI at Home is finally complete. And so in this video we're going to discuss what and how this project was conducted, and of course discuss the main results and the exciting signals discovered so far. Although if you're here to hear me say that, yay, we found alien life somewhere out there, unfortunately you're going to be very disappointed. But the project is still super exciting, and there might be part 2. And so let's discuss a couple of studies from the Berkeley University and basically all of the data analysis so far, and of course discuss the results. As always, you can find both studies in the links in the description below. But in case you've never heard of this project or you actually have no idea what SETI at Home is, let's of course briefly discuss the project as well. And it all started back in 1999. Here, this really exciting citizen science project allowed regular people like you and me to essentially loan your computer power, or basically processing power, to scientists at UC Berkeley in order to analyze various radio signals collected by the legendary Arecibo Observatory in Puerto Rico. That's of course the observatory we've discussed several years ago, because unfortunately it fell apart. You can find out more about this in one of the videos from 2020. But it still was able to collect a lot of data, and so much as a matter of fact that it was just extremely difficult to analyze without some kind of a distributed computing power and without some kind of a supercomputer. And while according to the 2 major papers published in 2025, the team has officially finished the massive task of data analysis. And excitingly, they've discovered at least 100 signals that may be signals of interest. Now, once again, not aliens, but signals that are still kind of exciting. But originally, when the search just began, there was really only one goal. The goal was to find a technosignature somewhere out there, or basically some kind of a pattern inside the radio waves coming from everywhere, that can only be explained as some kind of an alien technology producing radio emissions. But because radio signals are so extremely common in the universe, and also because so many satellites and even smartphones and of course radio towers produce radio signals as well, over 21 years of detections, the software discovered approximately 12 billion individual radio signals. The project manager, David Anderson, describes these as momentary blips of energy, with all of them basically coming from different locations in the night skies. And so here the challenge was the fact that the space is just incredibly noisy. Everything from various exploding stars to even various molecular clouds containing a lot of hydrogen emitted some kind of a radio wave that would be visible to Arecibo Observatory. But the biggest culprit was of course humans. Humans produce a lot of radio frequency interference, or RFI, and it was basically the main contaminant in all of the data. Anything from microwaves down the road, to cell phones of someone driving next to the observatory, or of course satellites orbiting Earth, all created a lot of noise that could obviously resemble an alien signal. And so to handle all of this, researchers had to use a supercomputer. And for this particular project, they had to rely on a supercomputer from the Max Planck Institute in Germany. This was actually meant to filter out a lot of these false positives, with basically billions of them just being noise coming from planet Earth. And one of the clever techniques that they used in this case was something referred to as birdies. Essentially a kind of a fake signal, and specifically 3,000 of them, inserted into the data to see if the system could discover them, because they could then essentially erase all of the signals that appeared kind of similar to these fake signals as well, which allowed them to measure exactly how sensitive the search was and to identify anything that was not important. And so following the collection of data from 2 million volunteers from approximately 100 different countries, which was by the way dramatically higher than they expected, they only expected like 50,000 volunteers, by 2013 they already collected enough data to start making conclusions. As a matter of fact, at this time this was the largest computational project in history and was officially entered in the Guinness World Record book. Here in terms of computational power, it was doing something like 670 teraflops. And because this was such a comprehensive project, it was able to cover approximately 1/3 of the entire night skies. Here we're talking about billions and billions of different stars in the Milky Way galaxy, mostly focusing on the central regions and the regions where we think some kind of life might exist. And by itself, this was a ridiculously successful project. It was successful both in the scientific approach and in the practical approach as well. Okay, let me clarify this. In terms of scientific success, it established a new sensitivity level for the entire galaxy, allowing researchers to say with certainty that if there was a signal above a specific power level, they would have definitely seen it. And in terms of practical success, it essentially showed us that citizen science and using volunteers for computing was a viable and extremely powerful research tool that has since been replicated in a lot of different projects, especially in the field of biology. As a matter of fact, this directly led to the creation of a platform referred to as BOINC, Berkeley Open Infrastructure for Network Computing. It involves fields like medicine, biology, mathematics, climatology, and of course astrophysics. Here are just some of these projects that are still operational, and of course the projects that you can still join yourself. You can find the full list in the link in the description. But ever since this happened, the project was obviously in a kind of a hibernation state. Mostly because there were no more signals coming in, and the data was essentially just sitting there waiting for someone to analyze it. And more specifically, they had to find signals that would stand out. Signals that, for example, contain what's known as a Gaussian shape, or basically a rise and fall in power, which was the result of the rotation of planet Earth as the telescope was observing the night skies, and for example things like triplets and pulses, or pulsing signals that resembled digital transmissions, and not random noise. And they of course also focused on the famous hydrogen line, or the 21 centimeter wavelength, which is of course the frequency of hydrogen that a lot of scientists believe aliens might also use as a kind of a universal hello channel. And well, after years and years of analysis, out of 12 billion signals, eventually scientists narrowed this down to approximately 1 million, then to 1,000, and now finally to just 100. The top 100 most promising signals that seem to match a lot of different criteria. And so I guess the question is, what makes these signals so special? Well, most of them seem to be the right frequency, the right kind of a pulsation, and the overall power profile that we kind of expect from some kind of a signal super far away. But these are obviously just candidate signals, and right now the assumption is that these are just really exciting radio signals from some kind of a natural source. So nobody right now is expecting these to be actual civilizations calling us, but they're still going to be investigated again, and the additional observations are already ongoing. For this, the team is currently observing these signals using the China's FAST telescope, which today is the world's largest single-dish radio telescope, and is even more sensitive than Arecibo. As a matter of fact, it's at least 8 times better at collecting data. And so the researchers behind the study are spending approximately 15 minutes looking at each of these 100 spots to see if these signals reappear again. And if they do, and if they resemble something they were producing previously, that's actually going to be kind of exciting, because it means that something in these regions is indeed producing signals we might expect from something that could be artificial, although right now it's still assumed to be some kind of a natural source. As a matter of fact, for example, the famous wow signal we've discussed previously has definitively been determined to be a natural source and not an alien signal. You can learn about this in one of the videos in the description. And so I guess here it's important to emphasize that right now this is not a smoking gun for, hey look, aliens are talking to us. Instead, this is evidence that our technique of data collection seems to work really well, and we might have discovered 100 different sources we never knew about before that could be caused by something exciting like some kind of a molecular cloud or a previously unknown pulsar. As a matter of fact, one of the researchers from the study, Eric Corpella, even admitted that he was a little bit disappointed that none of these signals really sort of jumped out saying that, hey look, this is alien life. Pretty much all of the signals right now just looked like natural sources. But in this case, a null result is still a result. By not finding an alien signal, we have now established this new sensitivity level for the entire galaxy, while also establishing a kind of a baseline for what we kind of expect most natural signals to look like. And so because this search was so extremely sensitive and involved such a large portion of the night skies, scientists now have a pretty good idea what to expect from natural sources and what to, I guess, ignore next time. But this search for extraterrestrial intelligence and some kind of a technosignature is obviously not over. And that's because we also have other initiatives like the Breakthrough Listen project that's using the Green Bank telescope to scan thousands of additional stars or to even look for optical signals and laser emissions from a lot of locations that could be a little bit more exciting. As a matter of fact, that's the project that already analyzed some of the most exciting signals, for example one from the Proxima Centauri and the planet K2-18b, where scientists have claimed detection of some kind of life. And of course the interstellar comets that made a lot of buzz in the last few years, including 3I Atlas. And so even though SETI at Home is finished, Breakthrough Listen is still going very strong, with researchers suggesting that because the technology has improved so much, all of this will actually be a lot easier now, and starting a new project like SETI at Home could allow researchers to process even larger chunks of data and analyze even more signals almost in real time, especially if we link them to data from telescopes like FAST and Meerkat in South Africa. And so by using better algorithms and even a bigger network, it may be possible to find something out there. But in this case, this essentially reminds us that search for extraterrestrial intelligence is most likely going to be a kind of a long-term endeavor. Even though a lot of scientists at first assume that we might find something pretty quickly, and there might be a lot of different civilizations trying to communicate at all times, after decades and decades of failed search, we now realize that all of this is going to require a lot of patience and a lot of rigorous analysis. And for all we know, based on some other studies, we may actually never find anything. But even though no signal has been confirmed yet, because we are getting so much better at listening to this great silence, we'll definitely discuss some of the other research and some of the other studies in some of the future videos once those studies come out. But hopefully in the next few years, someone comes up with even a bigger project, possibly turning the entire planet into some kind of a giant listening post, essentially revolutionizing how we collect data and involving even more volunteers, beating previous records. Although I guess until that happens, at least for now, SETI at Home is still the record holder, the biggest and the most successful citizen science project in human history. And a project that used to run on my own computer for a very long time, until my computer caught some kind of a virus and I basically had to wipe everything. So yeah, fun times. Anyway, we'll definitely come back and discuss this more some other day. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.